A single tiny mistake in PCB fabrication can lead to total product failure, project delays, and thousands of dollars in redesign costs. But how does a digital Gerber file on your screen transform into a highly precise multi-layer board that operates flawlessly for years in demanding industrial, telecommunication, and electronic systems? The PCB fabrication process is far more than just simple acid etching. It is a highly engineered blend of materials, science, precise chemistry, CNC machining, and advanced quality control systems. In this video, we are going step by step into the PCB production line, exploring every single stage, from Gerber and DFM reviews to photolithography, etching, drilling, lamination, surface finishes, and quality testing. You'll also see why even the smallest slip-up in any of these steps can compromise the board's final performance, and why choosing the right manufacturing partner is one of the most critical decisions for any electronics project. It all starts with your design files, known as Gerber data. This data is first reviewed by factory engineers to check for manufacturing errors or DFM issues. Once approved, it's time for the raw substrate preparation. We start with a core made of materials like FR4 or Rogers, which is clad in a layer of copper. To transfer the circuit design onto the copper, a photolithography method is used. A photosensitive film is placed on the board, and by exposing it to ultraviolet light, the structure of the traces is locked onto the board. Immediately after, the board enters the acid bath or etching line. At this stage, the chemical solution dissolves and washes away all the unprotected copper. The result? Only the precise copper traces and pads from your exact design remain on the board. Now it's time to connect the layers and create component mounting holes. CNC drilling machines work with incredible speed and accuracy, creating holes as small as a few microns. These holes are later coated with a thin layer of copper to establish electrical connections between the different layers of the board. If your board is multi-layer, the inner and outer layers, along with insulating layers called prepreg, are laminated together under immense pressure and high temperatures inside a press machine to form a solid, integrated structure. The slightest drop in pressure or incorrect temperature setting during this stage can cause the board to warp or break the vias. To protect the board against oxidation and unwanted short circuits during soldering, the famous solder mask layer is applied. While the nostalgic green color is the most classic, today modern boards also use black, white, or blue. Next comes the component guide, or silkscreen. All logos, part numbers, and reference designators are printed onto the board in high resolution so that the assembly engineer or the pick-and-place machine knows exactly where each component should sit. Finally, depending on the project requirements, a surface finish like ENIG or HASL is applied to the pads to maximize solderability. But a production line means nothing without quality testing. In advanced factories, boards must pass through strict testing gates before leaving. The Automated Optical Inspection System, or AOI, uses ultra-advanced cameras to compare the board layer by layer with the original design file to ensure there are no opens or shorts. Additionally, with an electrical test, the continuity of all traces and vias is 100% guaranteed, giving you peace of mind about the board's stability under harsh conditions. As you've seen, the final quality of a PCB doesn't just depend on its design. It relies on the precise execution of every manufacturing step, from engineering file reviews to final quality control. If you are designing or developing multi-layer, high-speed RF or industrial electronic products and want to prevent potential design and fabrication issues before going to production, the HighPCB engineering team is ready to review your Gerber and DFM files. To get technical advice, request a quote, and review the manufacturability of your project, connect with our experts through the link in the video description. If you found this video helpful, make sure to subscribe to the channel and hit the notification bell. In our upcoming videos, we will dive even deeper into PCB manufacturing, assembly, and professional design tips. Thank you for watching until the end, and we'll see you in the next video.